solving quadratic equations. So today we are talking about solving by factoring or using the square root property. Officially, some of you, we've talked about it just a tiny, tiny bit. But we will be doing, I think all week we'll be solving quadratics. And so we basically do like a method a day. There's 4 different methods for solving quadratics. The nice thing is on the test, I don't care which method you use. You pick the one that you like best or the one that works best for you. Some of them work all the time and some don't work all the time. So today with factoring and the square root property, these only work some of the time. Okay? Using solving by factoring or solving by taking square roots only works some of the time. But the reason we learn these is because they're the fastest. All right? They're definitely the easiest. But they don't work all the time. So it's, it's a trade-off. So my first question to you is 5 times x equals 0. What's x?
0.
Time.
Sorry,
yeah.
Yeah, that's what I
All
thought.
right. 6 times b. Oh, I didn't want to do that. Equals 0. What's b?
0.
Why? I don't understand.
6 times 0 is.
Oh, yeah.
Oh, okay. All right. A times 7 equals 0. What's A? 0. Okay. All right. So what I'm illustrating to you is the zero product property, which says if I have a product and I have 2 things multiplied together, A times B, and they're multiplied together, and if they are equal to 0, then it must be true that either the A is equal to 0 or the B is equal to 0, or both. If we have a product, we can set each part equal to 0, and we can use that to help us solve. We're going to use the zero product property for quadratic functions, for higher order polynomial equations as well, if it's set equal to 0, and that is the key. So we want to make sure that if we have an equation that is x squared or x cubed or x to the 4th, okay? So if it has a higher power than 1, then we solve using the zero product property. Always, always, we're going to set our equation equal to 0. All right? And we're going to try to write things as products, which is another word for factoring. So let's try a couple here. Example 1, solve each equation by factoring or the square root. About when we get there. Solve each equation by factoring or square roots. We have x squared plus 2x minus 15 is equal to 0. So first thing, is it set equal to 0? Yes, it is. Very good. So you'll notice we have 3 terms here. That's really important. Because we have the x squared and an x term and a constant, we actually can't use the square root method. We'll talk about the square root method in just a minute. We're going to solve this one by factoring. We have a trinomial. We're going to try to factor, or double bubble. Okay. You're good at factoring. What times what is x squared? X times x. And last times last has to be negative 15. What times what is negative 15? Positive 5 and negative 2. Now, 3. Thanks. That's better. Sorry, you saw where I got the 2 from, right? Okay. Thank you. Okay. Now we are in the zero product property situation. We have something times something else. Two things multiplied together, set equal to 0. So we get to set each bubble equal to 0 and solve for x. So I'm going to get x equals -5 and x equals 3. Do you think you have to show this step? No. Ladies and gentlemen, what is the highest power of this equation?
X squared.
2. The 2 is the highest power. Good. How many answers do we have?
2.
Always.
I don't like that.
Always. Ladies and gentlemen. Okay? Whatever your highest power is will always give you the number of solutions you should find. Good to know. Okay? Letter B. 6x equals. Hey, guess what? You can use your calculator to do this too. Did you know that? You got to get that fixed, man. I just want to show you. I like to point this out now because this is, I think, the most important thing is when we look at an equation that we know what it looks like graphically. So you can check these really easily because when we solve for x, we are finding x intercepts. Always. All right? So, which means if I take this equation, not the equal 0 part, but just the left-hand side, I can plug it into my y equals menu, and x squared plus 2x minus 15. And I can look at the graph, and you'll notice, where does it cross on the x-axis? -5 and 3. All right, so you can use trace if you want to, and you can type in -5, and you can see it's when we're equal to 0. And you can type in 3, and you can see that's where we're equal to 0. All right? Really, really useful stuff, ladies and gentlemen. Okay? If you were to use your calculator, you would draw me this picture. And you'd label this point 3, 0, and -5, 0 for your answers to be -5 and 3. Jonah?
So if it's like x to the third plus 2x squared plus x minus whatever it is, would that be like that?
It would. Mm-hmm. Yeah. All right. What do we need to do with letter B? Set it equal to 0. Yeah. Okay. How do you want to do that?
Chuck 6x. Move the 6x to the other side and make it negative.
All right. You guys are too fast because if you move this over, that you could. But I don't like factoring when my leading term is negative. Can I move these things over here?
Yeah.
Okay. So I much prefer that my leading term be positive. So I have a positive 8x squared plus 6x and then a -5. Are you guys good with that?
Yeah.
Okay. So you'll notice I wrote them in the proper order. This is typically called standard form or general form. Every book has a slightly different name. I wish they'd just call it ABC form, but I guess that would be too easy. But again, we can try to factor this. What times what is 8x squared? 4x times 2x. We also have 8x times 1x. So it's important to remember we've got other options. But I'm going to go with 4x times 2x first. And then last times last has to be -5. What times what is -5? 5 times -1 or -5 times +1. All right, so I want to go ahead and I think I want to do the +5 and the -1. How do I know if I did it right? Check the rainbow. Ladies and gentlemen, you must remember to check the rainbow. When I check the rainbow, 4x times negative 1 is negative 4x. 5 times 2x is 10x. And when we add those together, what do we get? 6x, so we know we did it correctly. Okay? All right, so that is set equal to 0, and now we can utilize the zero products property, which says what? Set each bubble, that's what it tells you to do, set each bubble equal to 0. And now we can solve for x. So what am I going to do over here with 4x plus 5? Minus 5, and then divide by 4. So negative 5/4. 2x minus 1 equals 0. We're going to add the 1 and divide by the 2. And so these are our two solutions for x. And could you check that on your calculator? Absolutely could. There's a couple of ways you could do it. But again, the easiest way would be to just take this equation and plug it into y1 and find the x-intercepts. Okay. So no, I prefer fractions, but that's just me. Mathematically speaking, the correct answer to that question is this as a decimal is negative 1.25. This decimal is a terminating decimal. This decimal is 0.5. It is a terminating decimal. Therefore, these are incredibly equivalent. Either one is appropriate. Okay, now if the fraction was 1/3 and you gave me the decimal 0.3, that would be wrong. Why?
Because it's repeating.
Yeah, because it's repeating, and that's just never a good. I mean, even if you put 0.33, fraction is better if it's a decimal that goes on forever.
I put 0.3 repeating.
So you'll never see the repeat bar in higher math, ever. Ever. We don't do it. So this is my thing. If you see a repeating decimal or a decimal that goes on forever, just use the fraction. I know, why learn the bar? Yeah, I know. Okay. Letter C and D are a little different. Oh, there's more. Yeah, there is.
Oh my. I saw that.
Oh, 5. Oh my God. God forbid. What's different about this one?
There's no middle to the first power.
Yeah, there's no m to the first power. Very good. So this is, we just have something being squared. And because there's no sort of what we would call the middle term, okay, so there's no middle term. This is a good question to use the square root method. Square root method. You can solve it by factoring. But like letter D, we actually want to do the square root method. So we're going to do the square root method. When we use the square root method, we want to isolate whatever's being squared. Isolate whatever is being squared. And so you can see here, we have the m is being squared, and we want to isolate that. So how do I get rid of the 2? Yeah, we're going to start by dividing off that number out in front. Isolating whatever is being squared. 150 divided by 2 is 75. And then, if I want to get rid of the m squared, if you want to get rid of that power, what's the inverse of a square? A square root, sure. When you take a square root, what must you remember? A plus or minus. There's always, when you're doing it, there are 2 numbers that you could square to get the positive 75. So you always have to remember the plus or minus. The square root of m squared cancels out, and you get m all by itself. And then we have plus or minus radical 75. Break apart 75 for me. 25 times 3. And simplify the radical. 5 radical 3. Very good. The square root of 25 is 5. We can't do the square root of 3. So we have 2 answers. 5 radical 3 and negative 5 radical 3. And if you want to leave them just like this, that is perfectly acceptable. Do you think that's something you could check on your calculator? You absolutely can. Let me show you. So just watch. So again, if I'm going to do this in my calculator, I'm going to set it equal to 0. 2m squared minus 150 equals 0. So I'm going to put that left-hand side in y1. 2x squared, I don't have an m, you just use x, minus 150. And I'm going to graph that. Ooh, he's a big kahuna. There he goes. Okay. So you can see I'm not seeing all of my parabola, am I? It goes way down here. But that's okay. I'm only interested in my x-intercepts. So again, I'm going to use trace. You guys, you might not care, but others might. So close your holes. Okay. Thank you. I'm going to use trace, and I can type in 5 radical 3. So literally 5 and then the square root of 3. And it'll, there it is. That's where it's equal to 0, which is what we're looking for. And then I can also type in negative 5 radical 3. And there again is where it's equal to 0. So nice to be able to use that to double check your answers. All right, letter D looks a lot more complicated. Do you think we're going to try to factor this or use the square root method? It is a square root method, and what we want to understand is that this is kind of the same thing. We have a thing that is being squared, which is easy to isolate. And so we want to isolate that and use the same method. So how are we going to isolate that? Add the 5 first. Good, so we can add 5. So I have 2t plus 3 quantity squared equals 34?
Yes.
Okay, thank you. And now, how do I get rid of my power of 2? Square root both sides, don't forget. Plus or minus, okay. The square root and the square cancel out, leaving the guts, 2t plus 3. The guts of the equation, the inner, does that make sense to you? Anytime I can make something bloody and gory, I'm all for it. 34, can I simplify that at all? No, so it just stays radical 34, no pairs in there to take out. And then our job is still to try and isolate the t. So what should we do? Subtract 3. So I have 2t equals, now this subtract 3 is going right in front of that plus or minus, negative 3 plus or minus radical 34. You could put it on the outside here. You could do subtract 3 if you wanted to. This is just the traditional way you'll see it. And then how do you get t by itself? Divide everything by 2. And so you could just write it like this, negative 3 plus or minus radical 34, all divided by 2. It's a lovely answer if you want it that way. You could also divide each piece by 2. This would be an equivalent answer. I only do this when I know something will reduce. Can I reduce the radical 34 and the 2? No, you cannot. Why not? One is totally radical and one is a regular Joe, and they just don't mix. Thank you so much. Super exciting. Oh, that's okay. Oh, I love it. Thank you so much. Have a good day. All right. They're slippery little suckers there. All right. So again, this guy's totally radical, and this is a regular Joe, and they don't reduce, so don't try to. Okay. Last one. Now, actually, you can solve this by factoring. You would never want to do that, though, because it would require you multiplying out z minus 4, foiling that out, distributing in the 2, And then subtracting the 7 and combining all your like terms and setting it equal to 0 and then double bubbling and solving from there. You don't want to do that, but you can. I mean, I'm just giving you options, okay? So, do you want to use the square root method then, I bet? Okay. So, what are you going to do first? Isolate by doing what? Adding 7. Always want to do any adding or subtracting first. Z minus 4 quantity squared equals 54. Then what? Divide by negative 2. Oh, wait. Okay. And that would be negative 27. Okay. And then how do we get rid of the power of 2? Square root. Don't forget.
Plus or minus.
Always, always, always. The plus or minus. So we leave the z minus 4 on the inside, the guts, that's right. And we have a plus or minus, very important. Can we simplify radical 27?
Yeah.
Yes, very good. Okay, I'm glad you remembered our fun friend I. We have a negative 1. What's the square root of negative 1? I. So an I comes out. What's the square root of 9? 3. And then we can't do the square root of 3, so it just stays. You can see how that's all one term right there, 3i radical 3. And the plus or minus is out in front. No. We want it fully simplified, so you pull out the i's. Yeah. So anytime you guys are going to find a negative in your answer, it's going to be imaginary. So pull out the I. And then we need to do what? Add the 4 to the other side. So we're going to get z equals 4 plus or minus 3i radical 3. Huh. You do have to take the I out. Are you going to be able to see this on a calculator? No. It's imaginary. It ain't really there. Okay. Do you know what this looks like if you were to graph it?
It doesn't show up.
It is floating. Let's see.
Isn't it floating
It's floating towards you. Yeah. It's floating above the x-axis. All right. Does it have any x-intercepts? It doesn't have any real ones. It has
So you're saying
imaginary ones.
that in the imaginary world, the x-axis is inverted.
I don't know.
Where's the fake x-axis?
I bet that's all it is.
Where is the fake x-axis?
Yeah.
So, I'm not exactly sure how it works. Like, you can graph these on an imaginary axis and a real number axis.
So it's
if
like
you
a
want.
fourth dimension.
It's kind of, yeah, maybe like a fourth dimension, but we don't try to graph it. This is your answer. Yeah, you gotta solve for it. All right, ladies and gentlemen, have fun. This is class practice 37. Oops.